Hey everyone, my name is Banu Raghuraman, and I'm very happy to be presenting on this topic of what machines can teach us about ourselves. First of all, I would like to introduce myself. I am a product and program management professional. I've had the benefit of working in different domains. My primary focus has been in fintech, but I've had exposure to other areas as well. My first background was in engineering, so I love problem solving, and that kind of made me go into some of the other areas as well, such as my MBA. My most recent educational background was in data analytics and big data, which I completed last year. I've also had the fortune of working in different countries and companies that are located in different countries as well. So, a wealth of knowledge in terms of working with different cultures, exposure to different types of work ethics and work ways. In my spare time, I enjoy mentorship and public speaking because I find this to be a great way to not just give back to the community, but also improve my own knowledge and information on things that I want to improve on or even learn more about. And last but not the least, I'm very happy and proud to say that I was one of the top 10 women selected as part of the SAS Women in Analytics casting call that just took place. And it's one of the first time that they have done this initiative. And I was very proud to be selected as part of that group of very, very knowledgeable women. So let's delve into the topic. I think the very fact that this topic has come about is mainly because I think machine has indeed evolved since earlier times. I think we have a different definition of what a machine is. So let's just explore a bit more on what this is. I think machine is still something that helps us accomplish a task much easier. So when you think of tasks that require a lot of repetition, tasks that require a lot of physical strength that you need to apply to make sure that you are able to accomplish something, or even reducing the amount of time it takes to do something. Does it much faster with stronger motors, stronger powerful motors, or even the data that it has handy, which makes it easier for us to determine things. For example, every day you step out, you kind of check the weather on your phone. It's really at the tap of your button. In some cases, you set up notifications to remind you that, hey, it's going to rain today. Why didn't you pick up your umbrella? So it has made it easier for us to accomplish a specific task. It can follow a series of programmable steps. So if you were to bring in automation, that's definitely a possibility because we know that the machine is able to, complete those tasks in sequence, and therefore we can set it up to be a programmable process. It requires some form of servicing or updates. It could be because the algorithm needs to be updated for some recent trends and changes. So, for example, if you moved from northern part of USA to the southern part of USA, there's going to be a massive change in climate. So you have to go in and kind of update your phone to say that don't ping me every time it's 10 degrees now, because I'm actually in a warmer climate zone and 10 degrees is going to be the normal temperature. If anything, it's going to be even more hotter. Or even if you think about roller coasters in some of these theme parks that we go to, when is it important that we service to maintain the roller coaster safety? Um, However, like I said, it has evolved from these traditional boundaries, and here are some points where I think it has changed quite a bit. It definitely has some level of smartness attributed to a lot of different factors. The first thing is that it's able to collect data now. We don't have to constantly keep feeding it. It's not about someone going in there and uploading spreadsheets and spreadsheets of Excel data, but it's able to get a lot of information from the environment. When you think about Internet of Things, you think about all these sensors that we're working with, alarm sensors for carbon monoxide, for motion detection, for temperature changes, for precipitation. And all these things actually help you regulate the temperature inside of your home. You start thinking about how smart these machines are to detect all these things. The next thing is analysis and prediction. So simply based on the data that it has collected, it's able to make an educated guess. It's able to make a good guess of what temperature should be within the house. It's got the ability to supervised and unsupervised learning. So continuing on the theme of thermostat, it's able to tell you, what's the average temperatures that your house tends to range in. It gives you suggestion about energy efficiency and what you need to do. Internet of Things. It's just something that's so pervasive now that it's available everywhere. Everything is connected through different types of sensors. There's data that's in the background that's driving these things. When you think about the Google suite of apps, there's just so many different ways that it's collecting data to create a persona of yourself as a user. It's creating an image or a visualization of who you are as a person. And last but not the least, it's able to move between manual and automated input. So on some days when the thermostat is not touched at all, it knows that within the house, we need to maintain this temperature range, and therefore it keeps the thermostat at that level. But on other days, maybe the owner of the house just went for a really, really intensive jog, and they're just sweating, and they just need a cool blast of air inside the house. So even though the temperature setting is set to a certain amount, they are able to do manual intervention to change the temperature in the house so that it's a bit more comfortable for them. So that's sort of what I want to keep in your view. Keep that in the back of your mind when you're thinking about machines in general. And these are the aspects that I'm looking at. So the three key takeaways at the end of this presentation, I want you to understand that these are the three ways that machines help us. So the first thing is it helps us confirm or reject our biases. It helps us make connections in terms of things that we hadn't thought of before. And last but not the least, through that, we're also able to identify gaps. Because if you realize that, oh, there is this strange connection, maybe I need a bit more data on it, you're able to identify that gap and kind of bridge that gap as well. So going into the first one as biases, hypothesis testing is something you must have heard of, and hypothesis testing is nothing more, in my opinion, than testing your biases. You look at a certain piece of data, you leverage some of the experiences that you've had in life, and you say that maybe ABC is true, and null hypothesis is probably ABC is true, and yet then your alternate hypothesis is that ABC is not true. Now, you approach this information with a type of bias, that's your hypothesis, and then you use data to confirm or reject that hypothesis. So when you think about some of the way biases are introduced in our thought process, I wanted to share some examples with you here. The first thing is crime detection. And this graph here is showing you how accurate some of these different products are in terms of detecting faces. And you can see that it's not that great for certain groups of people in the community. People with darker skin, it's harder to have better accuracy for their detection. Similarly, females. And when you think about the historical context in here, we know that both these groups did not have access to education for a long time. So they were not necessarily, their pictures were not really available. They were reduced to the lower strata of society for various political, racist reasons, sexist reasons, that they were kept outside. And therefore, there was not a lot of documented information about them. If that's the case, when you're feeding this information into the system, the data is going to be biased towards the fact that there are fewer samples for these people. Not to mention their presence in tech fields, in STEM fields as well. You don't have a lot of representation, and therefore you probably don't have a lot of sample set in there as well. So when this happens and this sort of technology is employed in crime detection, you can see the type of impact whereby it wrongly identifies people, which can have downstream repercussions in this person's life. So think about how that human bias and how historically certain things that have happened in our culture, in our history, has actually impacted this data that we're looking at. The next thing is financial lending. The credit score, although it's supposed to eliminate bias based on facts that are presented to you, that is not the case, because prior to the system coming into play, it was actually a person who was sitting there looking at these facts and figures, and then they made a decision based on their gut feeling and saying, if ABC is true, then I will give them the money. If any one of ABC is untrue, then I will not give them money. It wasn't necessarily completely based on factual things. There was a human element to it. And when you feed that data into the system as well, the system in itself starts becoming biased or reflecting the biases of the person who created that data. So these factors tend to have the same effect as someone who was privileged back in those days and at the same time prejudiced. So this is something that we need to keep in mind. And when we think about this financial lending concept, we're almost forcing people to remain in that cycle of poverty because the machine does not think otherwise. The next example that I wanted to provide was the political impacts that can happen due to biases in data. So in this case, even though Donald Trump was unable to carry the popular vote, but because they were the winner, or he was the winner of the Electoral College, he was the one who led the country for the last few years. So in that case, you can think about not just the bias in terms of data, but the process in itself that we implemented, this differentiation between popular vote versus electoral vote. Maybe initially it was used in a way to ensure that people's popularity is reflected in the Electoral College as well. But as time goes by, we're realizing that the feedback coming from the political circle is vastly different from what people want in the community. And that to us is a massive gap. And that's a process bias that we need to look at and make sure that we are aligned. Because at the end of the day, if politicians and people in such powerful positions are representatives of the community, yet there is a massive gap between their choices, we need to start thinking about whether or not the process that we're following is indeed correct. So that is something that is different from a data bias. It's a process-based bias. Last but not the least, something that even I have gone through is biases in hiring. So for the longest time, if you have a non-traditional name like you have, like mine, and it is also unpronounceable and somewhat long, people tended to toss those resumes out because they're like, okay, this is someone's name I can't pronounce, so I'm not gonna pick this person. However, when you're building these hiring algorithms, if the human element is what's actually feeding the system, similar to what we saw in the financial lending scenario, the system is also going to implicitly think that anyone with a name that it doesn't conform to a Western standard name rather than an ethnic name deserves to be tossed, rather than looking at the facts provided in the resume in itself. So the machine in itself is reflecting the biases of the human that fed the information to it. The next thing we're going to look at are connections. We all know that correlation is not necessarily causation. Just because two aspects of data that you're looking at are moving in the same direction and trajectory doesn't mean that one causes the other. There are different ways of checking this and looking at that with the correlation matrix, the causation tests, and so on and so forth. And this kind of connection is quite evident in some of the scenarios that we have looked at. One is the vicious cycle of poverty. Poverty and staying poor kind of has this circle which feeds into each, the next step that falls in that poverty circle. And it wouldn't have been obvious to us if we didn't have the data at hand. So if the financial aspects that we just discussed about was not as biased, perhaps someone would have been able to break through the cycle of poverty. But because we don't necessarily lend to people who have poor credit history, which tends to be people from the lower social status, which means that we keep them in their cycle of poverty and we don't necessarily let them break out of it. So this was an example of how, we made that connection through data, is that one bias is actually feeding into the next, which is feeding into the next, which is feeding into the next, causing that cycle to keep repeating itself. The next thing is diseases. We have made a massive leap forward in terms of how our biology and how biotechnology has really uncovered these relationships to diseases. When we think about the deficiencies that used to happen, polio vaccination that helped eradicate a massive issue, how water network and water infrastructure in a city can pass on diarrhea, cholera, understanding the Spanish flu and how that had implications with COVID-19 that we're all struggling through right now. These are interesting aspects that were only possible because the machines were strong enough to synthesize this data and give us those visualizations, and it helped us overcome our biases and what we thought was maybe happening, but in reality it was something quite different. The last thing I wanted to cover in terms of connections is this interesting article that I've provided the hyperlink for at the bottom. It actually pulled out some interesting nuggets of what data told us. The first thing was time spent in meetings basically shows how important you are at the company. So maybe this is obvious for someone who has been in the industry for a long time, but think about a newbie who's just starting their career. And for them, when they're doing stakeholder management or stakeholder relationships, it's something that they need to keep in mind is that if they think someone is important at the company and can be an important ally in the decision that they're trying to make, then include them in the meetings. So the more busy you see someone's calendar, being in meetings and blessing certain initiatives that are happening in the company, you will realize that this is an important person. Perhaps their title doesn't say so, but perhaps they are something like a godfather that kind of just goes into meetings and blesses initiatives and is a powerful ally to a lot of changes that happens in the company. The next thing is boiling point of water and time elapsed. So as we are polluting the environment more, as we are dumping a lot of chemicals in the water, the type of bonds that we're looking at between the molecules and the atoms, they are changing quite a bit. They're not the same as they were a few years back. And therefore, what has happened is that is slowly pushing the boiling point of water higher and higher because it's not the same texture anymore. It's not the same composition anymore. So in a way, scientists have realized that we can measure the time elapsed based on the movement of the boiling point of water. So last known boiling point of water was 100 degrees Celsius, but clearly it has moved as shown by this article. And perhaps it was moving for a long time until we discovered that like our point of history started when boiling point of water was 100. And prior to that, maybe it was something else. Last but not the least, age and wisdom. Traditionally, we say that as you age, you gain more information in life, so you become more wise, you go through more experiences, and therefore you become more wise. And to one of the recent books that I read, which is inspired by Marty Kagan, he also reiterates this point about, you need to spend about 10,000 hours doing a specific skill so that you become better at it. And that's just reinstating the fact that the more time spent on someone, and therefore you have aged and therefore you become wise, you start questioning about the alternate scenario whereby you look at the rise of Facebook, Netflix, Google, all the FANG companies that we talk about. And you start wondering, these were not necessarily built by people who were super old. These are not people who had a lot of experience when they built these products, but these were kids who were really interested in making a difference, and it was the passion that drove them and the knowledge of technology that gave them that edge to build these companies. So and now they are in leading positions in their company. They're C-suite executives, and these companies are still very, very profitable and doing quite well. So you start questioning this thought of, is age really equal to wisdom, or is there something else in the mix? Next thing I want to talk about were the gaps. So obviously, once you know that there are these connections and correlations, or when you're doing these data visualizations, you start realizing that there are these gaps that can be filled. The first thing is repeatable behavior. So since you have machines handy, if you are doing some sort of repeatable task that is manual, monotonous, requires a high degree of efficiency, or requires a high degree of correctness, you can definitely start looking into whether or not you can program these steps to be done automatically, and therefore bridge a gap of efficiency there, and push yourself to more strategic tasks, which is where humans perform quite well. What are the missed opportunities? What are things that you could have done better? Those are some of the gaps that can be addressed through data as well. And some of the missed opportunities I'm actually going to be talking about next. DEI initiatives are a massive one. Because the HR departments in various companies started collecting this data, and other initiatives and other social organizations that started collecting this data, we start realizing that DEI initiatives are really important to bridge that gap between the privileged and the not so privileged. How do you bring about an equality in society? Not in terms of the fact that everyone should be paid equally, everyone should be doing the same thing, but more of acknowledging the fact that someone has not had that privileged environment. So how do we propel them forward to be the best that they can be, or providing salaries for males and females at the same rate, and it's tied to the job that they're doing, tied to the skills and the value that they bring to the company, rather than their gender. So some of these aspects were only possible because machines were able to bring together a lot of this data and then give us that type of visualization. I've always wondered why it hasn't been applied to traffic jams yet. There's a lot of congestion in cities. A lot of people own cars now, and a lot of people are driving back and forth between different locations. However, we have GPS, we have the ability to track where a car is in its journey and so on and so forth. If so, and then we have access to people's calendars, and we're also able to track their daily activities based on where they are with the GPS tracking. If so, why haven't we been able to assess better of how well we need to design the roads? How do we need to control the flow of traffic? And what needs to be done to minimize this impact? The next two things I've personally been impacted by as well is immigration versus job markets. Especially for skilled immigration, we have a lot of people coming in with specific skills, and the government knows that they need to bridge the gap in these areas, and they do need those skills. However, when an immigrant comes fresh to a country, it takes them some time to find the right job in their own sector, because there's a gap between not understanding where these immigrants are actually going to go and kind of apply their skill set. So they're not necessarily familiar with the job market. They don't know who to approach or how to approach it, because it's a different work culture, different communities as well. So they are trying to learn a lot of new things, and therefore there's these whole set of skilled jobs that remain unfilled. But at the same time, there's a whole bunch of immigrants who do not really find a role in their sector or the skill set that they want to provide. So it's always boggled me that these two data points have not come together or come closer. And the next thing, in a similar fashion, graduates versus job markets. Apart from radical changes that happen in the job market, which you can't necessarily keep track of, there are some traditional roles that year by year. This is how many graduates that we churn out based on the schools, the graduation rates, and how many people come out. And then how many jobs there are yet to be filled. For example, nursing is something that is an industry that's facing heavy shortages right now, and it's always been a shortage, especially in the North American region. And we have tried our best to kind of supplement that through internationally trained professionals, through encouraging more people to go into that industry and so on and so forth. And yet there is a massive unemployment rate that we seem to keep battling as well, regardless of the society or community that we come from. But it boggles me that these two have not been connected much sooner and much in a better fashion. This slide is just a fun slide that I put together to see the pros and cons on both sections. So we've got the devil on this side showing all the cons, and then we've got the angel on the right side showing all the pros. So going through this, we know that through machines, we are able to see our biases, we're able to see the gaps in data, we're able to see a lot of the mistakes that we make, especially when you think about auditing history. Someone had put in the wrong data back in the day. They would maybe decipher it through handwriting because people had unique handwriting. But once we started moving on to the system, and it was very much the dot matrix type of era, everything just looked the same way. There weren't different fonts, but at the same time, we didn't really have audit history. It was really hard to trace back who did what at what point in time. But now with the system automatically monitoring things, we are reminded constantly of the mistakes that we make. And if someone else is looking at our document, then they're able to tell that we made that mistake too. It points us to the inefficiencies that we have in ourselves. We're not perfect. When you think about data entry, think about the number of mistakes that you make when you're typing in. And back in the day, we used to have a typewriter, and if you made a mistake, you had to go back and probably do it on a fresh piece of paper. Until whiteout came about, and then people started using whiteout. But still, there was a certain amount of planning that was required, and it really showed us how inefficient we were and how long it took us to become proficient in typewriting. But now with word processors online, with Word document online, we don't have to worry about typing the wrong thing. I don't even think a lot of people really care about spelling either, because spell checks have now come into these doc processors. So people don't even need to remember the right spelling. We've got that sense of entitlement to some extent, because now that we're working through these machines, we expect things to be done faster. So just because Google search happens in 0.03 seconds, we expect everything else to happen at the same pace. So we've gotten into the culture of instant gratification. We are constantly hooked onto social media to get that, to feel that high of constantly oversharing our information and being in touch with information, fear of missing out. The ADD, that there's a lot of these intricate psychological scenarios that have come about because of our connection and tie up with machines and technology. We have forgotten our simplicity to some extent. Gone are the days when you leave everything at home, you just take a walk outside without your device, or just take a deep breath and just revel in that joy. There are gaps between the real world and education. This is becoming more and more apparent, because the jobs that you actually do after graduation, save maybe certain industries, they don't necessarily map to what you studied at school. So the skill sets that you learn at school are quite different from what you actually need to apply at work. So on the pro side, it basically tells us there are opportunities to improve. We are humans, we are not infallible. So machines show us all these negative aspects, and we have the opportunity to improve ourselves. Creativity, this is still something that humans are able to do. It's not necessarily passed off to machinery. So coming up with out-of-the-box solutions, thinking about something in a different way compared to what it was done before. A lot of the entrepreneurial spirit comes out of this, when you're passionate about a certain aspect and you want to come up with creative solutions for that. The empathy aspect, we still are human because we can feel, and we haven't necessarily passed this off to machines yet. So bringing that relationship aspect, bringing that human aspect to our conversations. The ethical aspect of things, it's one thing whether or not something is legal, but there's ethics, there's integrity, there are these underlying values that we haven't necessarily passed off to machines. Our own potential. Yes, machines can do certain things, but their potential is limited to the point until where we have programmed it. So it can't necessarily go beyond that. But human strengths have been proven otherwise. They tend to come in ebbs and flows depending on how driven we are at that point in conversation. It's a good way to detox, leave the machines behind, and it's good to kind of detox. And it reminds us, machines constantly remind us, because we're overwhelmed with the amount of information, especially with this Zoom culture that has come about, where everything is online and you're sitting in front of a laptop doing things. You need to detox and kind of deconnect from things and become more complete on the inner side before you can come back. Family, focusing on family, just looking at your human relationships rather than just your technical relationships here. And last but not the least, the part that I said about the entrepreneurial spirit is the passion that we do our things with. That kind of passion is obviously lacking in machines. It's not something that machines can really express. So, in short, machines teach us that we're simply human. So, we have to stop pursuing this need to become more like machines, whereby people are working 24/7 a day. They're hardly taking any time for themselves. They're not necessarily easing into life, or that they're not detoxing in any way. So machines essentially teach us that we're simply human. So that was my presentation about what machines can teach us about ourselves. And to reiterate, there were three key takeaways that I wanted to share. One is confirming or rejecting biases. Second is making connections. And third of all, identifying gaps. Thank you very much. And my name is Banu Raghuraman, and I appreciate your time.